Hey brother, it is currently the 27th of September, the year of the Lord 2016, and today is Technology Tuesday, where I'm going to talk about some sort of technological aspect of the game. Today, software patterns. So you may not have heard of them, but there is a band of from Leeds in England called the Gang of Four. And they have nothing to do with Technology Tuesday, other than that, if you're looking up the Gang of Four scholars, Wikipedia is going to point you to the band in Leeds. So the reason why I bring up the Gang of Four is because they wrote a book called Design Patterns. Design patterns are common ways to solve problems that programmers run into a lot. And this is a really good book. It's not the most fascinating read, but it is a very good reference because I recommend reading through it once and then keeping it on your shelf as you program, because it does introduce a lot of good patterns, a lot of good practices. It's just a good book, and it is the examples are in C++. You should be able to pretty much follow them if you've done C#. But the concepts, the patterns themselves, are language agnostic. Some of them, for the most part, regardless of how languages come and go, these patterns are relatively the same. Some of them may not be as useful in certain languages. It does lend itself better towards the C family of languages, or very heavily object-oriented languages. But still, a very good read. Highly recommend it. So I'm going to show you one of the patterns that I'm using in my game, and this just scratches the surface, but I'm hoping it is helpful for you. So I'm going to switch over into the desktop mode here, and I'm going to open up Android Studio. So I'm going to actually show you two patterns here for the price of one. And these patterns are the Singleton and the Factory. And I've kind of intermingled them, so I'll try and separate them out. I'm going to start with the Factory because it's the most obvious one. And as you can see, I've created a class called Item Factory. I've got one called Merchant Factory, but it's really just a stub right now. So I'm not going to... I don't want to. It's not exactly something I want to show off. But Item Factory is a factory is a class whose job is to handle the creation of objects. And you may say, well, that's really simple. Why would you want to create a class to create other classes? And the answer is that sometimes the creation of an object is not simple. If it is, then you don't need a factory. And I don't recommend building it if you don't need it. In fact, there's a joke about Java programmers that before our program was, before Java, our program was in a different language and it had problems. We ported it over to Java, and now we've got problem factories because Java's just known for overusing this pattern. But the nice thing about this pattern is it does hide a lot of the instantiation of objects. So what I can do is I can add the factory to my code, and then later I can change how it instantiates objects, or even what objects it instantiates, and the rest of my code is none the wiser, making use, of course, of polymorphism. So, in fact, that merchant factory, which I wasn't going to show, is a good example of this, because this factory, all it does is it returns a sample or a mock of the merchant. And in fact, to show you what this looks like, I added it to my data classes just for testing purposes, and as I build this out, I added a static mock method which creates a very basic version of the item in question and returns it. And so this is just, sometimes I just need a merchant, so I can test, and this allows me to do it without too much of a hassle. But the cool thing is that my merchant factory, today it's just returning a mock. It's just returning the same merchant over and over and over again. If I change this to return a merchant from a list of from a list of merchants, or have it generate a random merchant, the rest of my code doesn't really change. The only time the code changes is if the factory needs more information to go on. So in this case, I'm probably going to change this signature to take in a string, which is the name of the merchant, or the type of the merchant, or something like that. And the way that I create merchants can evolve with minimal changes to the rest of the program. So that's the idea behind a factory. If you read the Gang of Four, they talk about it more from the idea of a factory. I may create a merchant factory, but then I may have a multiple subclasses of merchant factory, and depending on the subclass that I choose to instantiate, I can change the behavior of the merchant factory, if that makes sense. So I can start with a basic merchant factory, and everyone who uses merchant factory sees, oh, it's a merchant factory. But then when I actually create the factory, I can put in, I don't know, smart merchant factories that create smart merchants, or if in the case of items, I may have an item factory that reads items from a file. I may have an item factory that knows how to just generate random and bizarre new items. And I can switch out those implementations, again, without telling the rest of the code. So that's the idea, at a high level, that's the idea of the factory. So when I want to use it, and this is a little trippy, but going back to the merchant mock down here, I'm actually using, and I probably shouldn't be, but I'm actually using the item factory to get items to populate the merchant's inventory with. And so you can see the syntax to create an item is relatively simple. Nano beans have like 5 or 6 different attributes, right? Ranging from name to description, all the way to base value. I need to add a rarity index to them, and they could get more properties in the future. I only have to tell the factory which one I want, and then once I get it, I set a quantity, because that's going to be unique to this merchant. But that's really all there is to it. I don't have to worry about the rest of the properties. So the factory takes care of that for me. So that's why they're kind of cool. Now, you may have noticed that this merchant factory, because this is a very trimmed down version, it looks a little weird. If you were to read this code, you'd see that, wait, the constructor here is private. That means no outside class can call the constructor, which means no outside class can ever instantiate a merchant factory, which is weird. And the reason why is because I'm applying a second pattern to my factories called the Singleton pattern. The Singleton pattern is a pattern that is designed to make sure that you only ever have one instance of a particular class. This is perhaps the single most abused pattern, but it's a good one to know and to understand. And when I say it's the single most abused, is because the way that we implement this is we create a private static merchant factory variable inside of merchant factory, and then we have a method called get, which allows us to get that copy. Since the constructor is private, I can only instantiate the static merchant factory. I can never instantiate the other ones, or I can never instantiate outside. So this essentially contains the merchant factory class inside of itself, if that makes sense. Only the merchant factory class can create a merchant factory class, and so there's only ever one. This is really good if you have a class that is, that you never want duplicated. So for an example, I don't want my factories ever to get duplicated. I only want there to be one, because the item factory for example, goes and loads a list of items from disk, and it stores the definition for every possible item type inside this list of types. If I create a second item factory, I don't gain anything, and I duplicate the amount of data that I'm storing in memory. So I only ever want to have one. And making this a singleton allows me to do that. Now, the side effect of this, if I go back to Merchant Factory and we go back to see kind of usage of this in the, merchant's mock method here, say that 5 times fast, is that because this is a singleton, I can call this anywhere in my code. It's become a global variable, which is generally a no-no. We don't like global references because it makes it really easy to create dependencies you didn't intend to create, and it's bad practice. And so a lot of folks do create the singleton method just so they can have this global reference. And so you want to be mindful. It's kind of a gray area. There are camps that say singletons are evil, you should never create them, and there's sides that perhaps use them more liberally than they should. I just say it's a good tool, like a hammer. Just careful what you hammer. So yeah, that shows how singletons and factories work, at least at a very high level. I hope that made sense. I'm trying to go through it pretty quick because it's kind of late. One other thing, and this isn't a software pattern, it's just a cool thing, is I've gone and arranged my code into 3 categories right now. I've got data, and these are like my game objects, merchants, items, players, stations, the whole thing. I've got factories, and then I've got screens. And for my data items, like I'm going to pick on item as a very simple example of this. It's a very simple class. It doesn't have a lot of logic. In fact, I don't think this thing has any logic. It just holds data, and it says I've got this much of this type of item. Simple construct. One little trick, and this is just syntactic candy, that you can do is when you create setters, you can have your setter return the item itself. So if I create an item A, and I call set count will set the count, and then it will return the item that I just set the count for. And the cool thing about this is that you can use this to chain setters. So I can say item, then set count, set type, set, well, in this case I can't set the type. Maybe if I go down to the merchant, this isn't the best example either. An item type I don't have a lot of setters on. So I should probably have gotten you more examples. Actually, I can show you an example where I'm actually using someone else's attempt to do this. So I'm using a library for the GUI called Viz. The details aren't important, but I want you to look at this line of code. So I've got a table, and it's like an HTML table. It's just used to arrange things in an organized way on the screen. And notice that I'm setting, or that I'm getting the column defaults for column 0, and then I'm setting the pad to be 2 units, and the width to be 300 units, and I'm doing this in one line of code. I've got that same chaining effect going on here, and again, this is kind of syntactic candy. It doesn't structurally change how your code works, really, but it's nice because in the if I didn't do this, I'd have to have a line for each time I called set. So if I'm going to set 3 parameters, then I'm going to have 3 lines of code, whereas this allows me to set everything I want in 1 line of code, which is cool because the more lines of code you have, the easier it is to lose your train of thought as you're trying to understand that piece of code. And so by putting the setting down to one line, I can say, oh yeah, that one line deals with setting these attributes. And I can move on and keep the overall context of that function. So anyways, a very small thing. You've got, in C#, if you're using C#, you've got attributes that you can use for setters, which hide the getter and setter methods. So you may not use this, but I just thought it was kind of cool and I wanted to share. So with that, I think that's all I wanted to show you for Tech Tuesday. I hope your game is going well. I look forward to seeing your next video. And until next time, I remain your brother.